Hi good people, this is part 3 of our Frogger mini-series, and in this video, we'll script the movement code to get our player roaming around the map. Let's not waste any time and just jump right into it. Okay, so we got our player blueprint here. We're going to head back into the event graph, and last we left off, we were setting up the input system. We have that connected, and we are successfully firing our input actions. We used the print string to test that, so we will delete that code because we no longer need it. And we're actually going to get the movement code going. So first thing we're going to do is we'll pull off and search for a branch, which is a control node. You can also just press the B key, click into the graph, and it'll add all these various branch nodes. So it's a quick shortcut for you. The reason we need to check the branch is we need to validate that the player has not jumped or they're not in the air, because we don't want them to double hop or be able to jump while they're falling, for instance. So what we can do is we can use our character movement script, which comes default with this character class, which is why we used it. It makes our life a little bit easier because it has a built-in function called isFalling. And then we can basically use this to check if the player's in the air. I want the opposite of this, so I'm going to pull into a not boolean, and then I'm going to pass this into the condition value here. So I'm basically saying if the character is not falling, then I want to call some function. The function I'm going to call is actually going to have to be a custom function we're going to write. So under functions on the left, there's this little plus sign. Just click on that, and it allows you to basically define any custom function you want. This one, you can call it whatever you want. I'm going to do calculate player rotation, and then compile and save. We'll come back to this. So we're going to head to the event graph tab at the top, and off the true pin, I'm just simply going to call that that calculate player rotation. So after we calculate player rotation, I'm going to pull into another branch check. This one is going to check if the x-axis on the controller is not equal to 0. So why am I doing that? I'm basically checking, is the player moving along the x-axis, or should the player be moving along the x-axis? If they are, then we want to add some movement input function across some scale. Now the scale we can use, I'm actually just going to pass in the x value here. And just make that easier, we'll add a reroute node. Gonna make this a little bit cleaner. So there we go. So we'll basically have to figure out which world direction we're moving along, and it's only going to be the x and the y. The reason this is, normally you would think, oh, I'm just going to add it on the x-axis. It's a little confusing though, because we're not moving along the static mesh. We're moving along the capsule component. And currently, the capsule component, I think the way it's situated is actually on the y-axis. So we will want to come over here, and on the world direction, we're going to set the y value to be 1. And that'll make it so we move left and right when the player hits A and D. And we'll test that once we set it up to make sure. And then if this evaluates to false, we're basically just going to come into another branch check. But this time we're going to use the y value, and we're going to say, does y not equal 0? And then if y is not 0, is basically some positive value, then we're going to want to add some movement input, but instead of the y-axis, so we'll set that to 0, we want to move along the x-axis, so we'll set that to 1. And then what I can do is just pass in the y as our scalar. And then I'll add a little reroute by double clicking, add this in here. So basically this is the bulk of our code, so I can actually just comment and just call this our movement code. I'll give it a color, we'll do a different color, because why not? So basically when the player hits, WASD, check if the player is not in the air. If they're not, let's rotate the static mesh, And then we're going to check, are they moving on the x-axis? If they are, let's move them left or right. If they're not, are they moving on the y-axis? If they are, let's move them up or down. That's all we're doing. So now if we compile, save, and test, we're obviously not going to rotate, but we should be able to move our little frog around the map. And that's working mostly. But let's figure out the rotation piece. So we'll hit escape, go back to our blueprint, and we have our world direction set correctly because that did work based on WASD. So if yours are slightly off, you might need to flip these depending on how your capsule component's rotated, depending on which version of Unreal Engine you're running, so they might do things differently. We got to set up the calculate player rotation function now. So we'll go over there, and what we're going to need to make this work is we need the X and Y value from our controller. So we need some inputs. So we can hit the plus sign on this input, and you can call it whatever you want. I'm going to call mine the X-axis, and the data type was obviously a float. It's like the axis is -1 to 1. It's some range in between there. And then the second input we need, of course, is the Y-axis, and that is also going to be a float. Now, the way we're going to do this is we will simply pull into a couple branch checks. So we're going to hook up our branch checks like so. And if someone knows a way to do case statements in Visual Scripting and Unreal Engine, please leave a comment down below, because this is a little ridiculous. And I would just like to do a simple case statement, but maybe there's not, and maybe we're stuck this way. One of the benefits of doing C++ coding, I guess, cleaner code. So what we're going to do is basically check, is the x-axis greater than 0? And then we're also going to check, is the x-axis less than 0? And it is important you don't do less equal. It needs to be greater and then less than, because we don't want to include the 0 range. And then we're going to check, is the y-axis greater than 0? Alright, and I'm going to reroute that so it's a little bit cleaner. Right there. And then the last check we need to do is the y value less than 0? So why are we doing this? Why are we checking the axis values? So if we can validate if the x is greater than 0, that means the player's moving right. So I can take the static mesh, I can pull into a set relative rotation, and then hit true here. And then we need to figure out the rotation. Now, the way we do that is we look at our viewport and we figure out where the frog is currently sitting. So currently, by default, he's facing to the right. You can see down in the bottom left-hand corner. I know in our rotation tier 270, you don't want to match that. You want to match, because we're using relative position, what it is currently here. You could use global, and then you would match that. So you could do it that way. But for now, we'll just use relative, and we'll just offset what we currently have. So the frog by default faces right. So I don't want to rotate the frog at all. So I want to set that to 0. Now, if x is less than 0, it means it's a negative value. That means our frog is heading to the left. It means the player is pushing the A key on the keyboard. So I want the frog to do a complete 180-degree turn and go the opposite direction. Now, if the y value is greater than 1, means it's a positive, it means the frog is heading up, or it's traveling up. So the player is pushing the W key on the keyboard. So that's gonna basically need you could either do a negative 90 degree, or you can do 270 degrees. So one of those. So for this one, we'll keep it positive, and just do 270 degrees. And then the last condition check is if y is less than 0, means it's a negative value, means the player is heading downward. So we'll hook this up this way. That means we need to rotate 90 degrees to face in the downward direction. And like I said, if anybody knows how to do case statements in visual scripting, please leave a comment because I would love to not do it this way. But this completes the function, so now we can go to the event graph. You'll notice our calculate player has an input now for X and Y, so we can just simply hook in our X value and our Y value. So now we compile and we go back to the map. I could actually move around and I actually face the direction that I'm moving. Like so. All right, but that's only one of our enhanced input actions. We made another for leap. So let's go ahead and finish that one off to close out this little video. So we'll go back to our blueprint and we are going to right click, search for I_leap, which was the name of our input action that we made before. And then we're going to pull off into a simple branch check. The thing we need to check, or the thing we need to check is the same we checked before. We want to get the character movement component. Check is falling. And then I want the reverse of that, so I'm going to pull off and do a not Boolean. And then I'll plug this into my branch check. So I'm basically saying, is the player not falling? So if they're not falling, then I want to do this, which is launch the character, which is a fun little built-in function. It's very easy. You basically figure out whatever trajectory you want, and you can throw the character some distance. It's great. What you can do is you can right-click on the vector, and you can do split, and you can have individual access to the X, Y, and Z, which is perfect because I am just simply going to throw the player up in the Z axis by 1,000 units, and then I need to figure out how to move it along the X and the Y. The way we can do that is we are not rotating the capsule component, but we are rotating the static mesh. So I can use the static mesh, pull off that, and simply get a right vector. And when we say right vector, a lot of gaming development uses vector math. So if you're trying to figure out, how to move, you're typically getting like the vector length, which is the magnitude between two positions to figure out speed. You might be getting the right vector or the forward vector or the up vector to figure out how to rotate or move towards or, figure out what's next to a player, basically. So, right vector is obviously to the right, forward vector is facing where the player is facing, and the up vector is on the Z axis. It's typically going up from where the player's current position is. So I'm basically going to just figure out, using the right vector, I can split this, and then I can use the individual X and Y and multiply that. So multiply here, and we'll do multiply there. And I'm going to multiply that by some value, and then I can feed that into the X and the Y. In order to figure out which value I'm going to use, I'm just going to create a variable. This one will just do leap distance, and the data type has to be a float. And this one will set maybe 300 is good starting off. So we'll plug that in here, and plug this in here. All right, and now one other thing that we'll want to do in the launch character is we will want to override the X, Y, and the Z. That basically states that if the player has some momentum already from moving or being hit or already being launched, it won't be additive. It'll override it and only use these distances. And that might make it a little bit easier for making this right, or making this work. So now that I have this kind of set up, we can highlight everything, press C to comment, and we'll call this our leap code. Not to be confused with leet code. Okay, let me compile and save. Now we hook this up on our spacebar, so if I hit space, we can see our frog launches. And if I hit spacebar multiple times, you'll notice the frog will not launch if they're already kind of like moving there. And this is going to be, like I said earlier, I think how we'll handle the second part of the map. So the first part is the vehicles. The second part is the river. So I think the river will make the player have to time the jumps so they can figure out how to hop across the various logs and turtles and whatnot to make it to the other side. But all right, everyone, I think we'll cut the video here, but in the next one, we'll create the logic to drive our animation state machine so our player looks a little more lively when it moves around. But as always, thanks for watching, consider subscribing, and we'll see you on the next one.